Welcome to Khetz tutorials, and in this video I'll be doing question 38 from 1.1 exercises in geometry of calculus. So you're asked to find the domain and range of this function and finally to sketch it. So a logical approach which I would follow would be to find the domain first. So if you have the domain, then you have the list of all x values where this is defined. Then you're going to take the smallest x value, substitute it into the function, as well as the biggest x value in your domain, and those will give you the y. So if you substitute an x here, you're going to get an y. So the domain is x and the range is y. If you know the x values, you can figure out what the list of y values is. I hope that makes sense. So now let's start with the domain, and we just have the square root, and the condition, just like in the previous two or so questions, is that if you have an even root, so this is like 2, they don't usually write it, but that's what it is, then this portion has to be greater or equal to 0. So that is where this function will be defined. So that portion has to be greater or equal to 0. So now, if we were to find the critical values of this is 2 minus x, 2 plus x, that's basically the difference of 2 squares, and one of the x's will be 2, and the other one would be minus 2. So these are the two values which we have, and they act as boundaries for the behavior that we are trying to assess. So we want places where our function is either 0 or positive or greater than 0. Basically means the same thing. So let's assess these points. So at minus 2 and 2. So we're going to check the region to the left of minus 2, the region in between the two numbers, as well as the region which is to the right of 2. By picking a single number in each of these regions, we can define or decide whether those numbers will lead to a positive or negative result. So let's check that. If we were to pick a number to the left of minus 2, then let's say minus 3. Let's see what we'll have if we substitute minus 3 into that. So you're going to have 2 minus 3. And we're only interested in the sign and not really the answer. So this here is a positive, and that is a negative, which would lead to a negative. So on this side, we're going to have a negative result in this region to the left of minus 2. If we check a number which is between minus 2 and 2, let's take 0. It's a simple one to work with. So 2 minus 0, 2 plus 0. So this is a positive, and that is also a positive. If you multiply them, you can have a positive result. So any number which you pick between minus 2 and 2 will give you a positive answer, which is in line with this. Then if you go to the right of 2, let's say pick number 3. Then you have 2 minus 3, 2 plus 3. This is negative, that is positive, so the result will be negative. So to the right of 2, again, you have a negative result. We're only interested in portions where we have an answer which is 0 or positive or greater than 0. And that is this portion only. And now we have an equal sign there. At minus 2, if you substitute minus 2 into this, you're going to have a 0, which is included in the answer. If you substitute 2, we're also going to have 0. So this is a definition of your domain, or this is where your function is defined between minus 2 and 2 included. And your answer for the domain would therefore be x is an element between minus 2 and 2. If you try any other number which is outside of these x values, you'd see that your function is not defined. Now that we know where these are defined, or where the x values are defined, we can use that to find the range. So if you take the smallest x, substitute it into the original function, so let's see what y value we get if you do that. So 4 minus, then we're going to have minus 2 squared, and this is 4 minus 4, which is 0, right? So that is the we have one y value. So the smallest y value is 0 because this cannot be negative. So there's no negative sign outside, and the portion inside can never lead to a negative answer. So this would be our smallest y value. If we substitute 2, we're going to get the same 0. But if we scan through the numbers in here and we substitute a value which would make this expression the biggest it can be, you'd find that substituting an x of 0 leads to the square root of 4, which is the highest number which you can get, that is 2. So your range is a definition of the smallest to the biggest y value which you can find based on the x values that you have. So you can't test using any other x value. You can only use the x values which are in the function, and these are the x values we have. So you saw that the smallest one led to 0, the biggest one also leads to 0, but those are not all the y values that this function can take. If you substitute an x of 0, that is where this function is at a maximum. That is the maximum y value which you can get. Any other y value or any other x value which you get will lead to a smaller y value. So the smallest y value is 0, and the biggest y value is 2. Right? So we now have the domain and we now have the range. We only left with the sketch. So let's sketch. So sketch doesn't really have to be pretty, doesn't have to be accurate at all in terms of scale. You just have to have the correct intercepts as well as any other thing which they ask for. So label your axes, x and y. Then our function is defined between -2 and 2 included. So you're going to have these portions included or shaded like that. And it does not exist below this line because our y values are only from 0 going up. So y values only exist from 0 until 2. And if you look at the nature of this, or if you look at the function itself, let's forget the square root for a minute. If you only focus on this part, that is a parabola which faces downwards. And that is exactly what we're going to have. So imagine this original parabola, then find the square root of each of the y values on it. That would lead you to this function which we're going to sketch. So it's just a parabola that cuts at 2 instead of cutting at 4, just like it would if it were not under the square root. And that is the end of your sketch. So it does not exist to the left of -2 because of our domain, as well as to the right of 2. It does not go above 2 because that is the maximum y value, and it does not go down here for all the reasons which we basically talked about. So this is how you'd find the domain, the range, and finally sketch your graph.